Hey guys. All right, today we're going to talk about the measure of the outside of two-dimensional shapes. So let's go pull up this PowerPoint, hopefully. Okay, let's see how it goes. All right, let me share that with y'all on your screen. All right, let's kind of come up here. All right, so we are going to talk about perimeter, circumference, something called arc length. So most of this material is going to be familiar to you, but I do want to remind you of some things. Okay, remember that we're going to be measuring the outside and the inside of two-dimensional figures kind of this week, okay? So the outside is polygons or circles or parts of circles. So if it's a polygon, the outside's called perimeter, okay? And basically, all you need to remember is not really a formula, it's just a phrase. You just find the length of every side on your polygon and you add those lengths up, okay? So on this particular polygon, I just took the 6 inches and added to the 10 inches, to the 5 inches, to the 3 inches, and I got 24 inches. Inches plus inches stay inches, okay? Not square inches, just regular inches. And remember that a measurement's got 2 parts to it. It's got a number and it's got a unit. I need both of those things or it's going to cost you points, okay? You wouldn't just say that the length of the table is 2. Is that 2 feet, 2 meters, 2 inches, 2 miles? You know, you need both of those things. Now, these two sometimes you see formulas for, but really you don't need to memorize the formula. But I do want you to understand where the formula comes from. If you've got a rectangle, remember that opposite sides are parallel, but they're also congruent. So I'd have 2 of the 20s and then 2 of the 12s and get 64 centimeters. So sometimes you'll see a formula for a rectangle that perimeter is twice the length plus 2 times the width. That's where that comes from. So if your students have to memorize the formula to recognize the formula on a test, then get them to memorize it. But really, they just need to know to add up the sides. That's why you'll see this perimeter formula for a square sometimes. Since all the sides are the same length, you just say 4 times the length of one side. So 4 times 11 is 44. Okay? So again, if the students have to memorize those formulas for like a standardized test, then you need to teach them, but not, then I would just tell them to add up the lengths of the sides. Now remember, with a circle, it's not a polygon, so they don't call it a perimeter. Instead, they call it a circumference. So that's the distance around the outside of a circle. Okay? Now, what they found out was, though, here's kind of the way they discovered the formula. If you have a small circle or a giant circle, either way, and you measure the distance around the outside, circumference, and the distance across it through the middle, diameter, and divide those two numbers, we found out you always got the same answer, a little more than 3. 3.14159. Now, the reason it says etc., that number never terminates or stops. Computers have run programs to calculate it for weeks and never stops, never terminates. So they made a symbol to stand for it, which is a Greek letter pi. So this is actually the way it was discovered. Any circumference divided by its diameter on any circle gives you a number a little bit bigger than 3. So it's a little more than 3 times the length across it if you want to go around it. Then if you multiply both sides by d, remember those d's divide out to 1, and 1 times c is c. Now what property would say that 1 times c is c? That's right, identity property multiplication would say that. Very good. So this is your formula for circumference that you would need to learn. If you just take pi times the diameter, that's going to get your circumference. So here's a couple of quick examples. So on this one, all the way across the circle is 15 millimeters. So I just said 15 is the diameter times my pi, and I got 15 pi, but don't forget to put those millimeters there or you'd miss some points. Now, that's pretty abstract for a lot of people, especially for elementary students. So with them, you really want to change to an approximately equal to and substitute a decimal approximation for pi. 3 and 1400ths is kind of the most common, but you know, you could go up here and substitute that and get a more accurate answer. So if you substitute, though, you have to change equals to approximately equal to, okay, or I would count off on a test. So either exact answers with equals or approximately decimal approximation answers. Either one are fine for me on a test. Now look at this one. I need the diameter, but they didn't give me the diameter, they gave me the radius. But you know, if it's 4 halfway across, it's going to be double that, or 8 all the way across. So again, I got 8 times pi inches, or if you substitute 3 1400ths in for your pi, you'll get approximately 25 1200ths inches. And again, for me on a test, either one's fine. Now, let's go to arc length, which may not be as familiar to some of you. Arc length is just part of the way around a circle instead of all the way around a circle. So look at this one, okay? I didn't go all the way around. If I went all the way around it, I'd get 10 pi centimeters. There's my circumference formula. But I want to go part of the way around it. Do you see that I'm only going 1/4 of the way around it? If I did 4 of those, I'd be all the way around. So my part is 1/4. Of is times, a lot of times we multiply in place of in math. And then there's my whole circumference. So remember, for math 210, single numbers go over 1, so I go straight across the top, 10 pi, straight across the bottom, 4, and then I reduce that 10/4 to 5/2. So I get 5 pi over 2 centimeters. Or approximately, when you substitute that decimal in for pi, I get almost 8, 7 8500 centimeters. Now, let's talk about a formula for it, because sometimes the part won't be as easy. If that were 23 degrees instead of 90, you'd probably have a harder time. So the way you always find the part is you put your angle measure over your 360. See, my angle measure up here was 90. If I were to put 90 over 360 and reduce it, I would get my 1/4. So this is the formula, so to speak, for arc length, just part times your whole circumference. And that pi d is just the formula for circumference. All right, let's work a couple real quick, just to make sure that you're okay on your homework. There's your formula again. Okay, part, angle measure over 360, times your whole circumference, pi d. All right, all the way across is 13 meters. My angle measure, if it's 360 degrees in a whole circle, that's why it's 360 on the bottom. It's 360 degrees around a whole circle. And we only went 180. Remember, a straight angle is 180 degrees. If you reduce that, you get 1/2. Single numbers go over 1 to make them fractions. You multiply straight across the top and straight across the bottom. So that's where I got 13 pi divided by 2. And then don't forget to put your units on there, meters. If you want to change to a decimal approximation, that'd be fine. It'd be your choice. All right, look at example 2. I'm telling you the measure of angle AOB. That angle right there is 120. So I want to know how far it is from A to B. If an ant crawled around that part of the circle, how far would the ant crawl? So remember your formula, your angle measure over 360. Well, your angle measure is 120. Pi, your diameter. Now that 8, remember, is your radius, so you would double that to get your diameter. If you put those two numbers over 1 and you go straight across the top and straight across the bottom and you reduce it, you'd get 16 pi over 3 inches. Then if you replace that pi with 3 1400ths, this would be your decimal approximation. 16 and 7,467 10,000ths inches. Okay? So it's pretty straightforward. I don't think you're going to have any trouble with it. So go try that homework. Okay? Let me know if you have any trouble with it. Okay, let's stop this PowerPoint. Let me know if you have any trouble with it. Okay?